So now I am heading into my second lecture. So I know this is where you might have seen, so many experts, so many lectures, because this FDP itself is on hydrogen and lot of details. Again, as I am saying, typically in FDPs, we don't try to take just one paper or don't try to take one system, start explaining 20 equations there. That is good, nothing wrong. But with that, it may not benefit every participant of that FDP, because a lot of the participants may be already experts, or they may be doing certain areas. They want to know where the future is headed, which areas are going to be important, how do I benefit. So if I start to explain you 10 equations at the end of, and if you think, oh, I just saw only 10 equations, beyond that I did not learn much, that doesn't benefit much FDP. So the whole way, what I am saying is, the way I try to arrange the material here, we do some work. I'm not saying that a lot, but still we do some hydrogen side work too. And fortunately, we had some great PDFs or postdoctoral fellows or students who did good work. So that's what I took some of the pieces, which I'll be showing. So the way I arranged here is, last 5 days, whatever hydrogen side you saw it, you may be seeing here some sort of a linking of them. Also, I'm going to show you, this is, I think hydrogen is one of the heavy focused energy side research opportunity, not only in India, not only in Canada, US, or worldwide, because in future we are headed in a way that we want to reduce the role of fossil fuels. We want to have better and cleaner systems. What I mean is in terms of emissions reduction, please. So if that is the case, how does this hydrogen can help us, and where is it, and how is it headed? I know you might have heard from people talking some systems or some analysis, some combinations. Sometimes you may see some things might have been uh, put to a bigger magnitude. I'm just using the word bigger magnitude. Reality could be on a different side. Sometimes you may see some systems may be shown in a different way. Maybe they have a lot of opportunity. So we cannot simply say that this is this or that is that unless we see in a combination. So that's where the focus of this is. Okay, let me get on now. So as I said, I will try to, put some details that is related to advances and developments, particularly in the hydrogen side, which is now one of the hot topic, along with, when you look into the transportation side, electric vehicles. People talk a lot about these days, electric vehicles. Yes, no doubt, they are being produced. Slowly they are coming up. And on the hydrogen side, still, to be frank, there's a lot hydrogen spoken from 30, 40, 50 years. I think maybe slowly now it is catching up. That's, let us put that way. Compared to electric now, hydrogen seems to be lagging behind, but still now there is attention. Slowly it is coming up. Okay, so the as I said, if you notice, why do we focus so much on hydrogen? Why there is so much of attention on hydrogen these days? So as the trend is to move towards more renewables for various applications, that means we are trying to move slowly towards decarbonization side. And then the question is, this is what I am telling you. See, even any expert, any professor, when they give 1 or 2 hours of seminars, they try to give you some highlights, try to give you some details, given their time limitation. Not that they don't want to put details, but sometimes you may not notice everything. So here, the point that you need to observe as I go through some of the slides, some slides I may be highlighting a lot, some I may not, given the time limitation. You also need to notice, please. So we are talking hydrogen. Try to notice from where this hydrogen is produced. I may be highlighting 2, 3 questions. Where this hydrogen is produced, then what people stress a lot, then where is the opportunity, where are the problems. Whenever there is a problem, there is also opportunity. So I will highlight you those details. Then when you look into the hydrogen side, why is it becoming popular, or why we want it, not only to decarbonization side, cleaner side, these that hydrogen has a lot of applications too. It has applications on many sites if it is available in full. Lot of, even now, lot of hydrogen is utilized in industrial applications. Even the famous, even in California from long back, they paid lot attention on hydrogen. But still, I think the contribution of hydrogen there in that state overall is still not up to the mark. Even spending a lot from decades. I'm not saying 5 or 10 or 15 years. I think from probably 3, 4 decades, they are spending so much. Still, it is not up to the mark. So that means there are things to be worked. Does take time. So if we put under 3 headings here, why hydrogen is trying to be becoming popular, as we want to move to cleaner side, decarbonization side, then from where hydrogen is coming, this is where my focus of discussion is going to be lot, then lot applications. Okay, now let's get on. Give me 1 second. Okay, so the more focus of my discussion is going to be on the next topic, which is not on solar, but still I wanted to show you these days when people are talking, there's a lot of importance that is given, particularly how to produce hydrogen from solar. I'm telling you, this is a big area. So, as a researcher, as a professor, even if you are looking, this is where there is a lot of opportunity, even in India, as India promotes a lot renewables, even more stress on hydrogen. So producing hydrogen from solar is one of the big area. And if you say that, oh, there's already systems that produce, there's already research, yes, no doubt there are. But the thing is, I do show you where we stand, where we need to go. So why solar hydrogen is trying to become so popular or important is, it is a solar itself is renewable, it's a clean production, it's a sustainable. Then these two comes in. Where the research is, where the research needs are. I'm going to put a journal paper, I'll show you. Then what about economics? Pay attention, please. These two, if I club these two together, research advances and research needs with reference to solar hydrogen production. Economics, keep in mind in engineering, ultimately, whatever nice words somebody puts, they may talk a lot about lot equations and lot systems, but in reality, it cannot be separated from economics. Economics needs to support. There's nobody who will pay too much when economically something is available at a cheaper rate. So that means economics matters a lot. Okay. So I will, as I said, I will be showing a journal paper too. Again, given the time limitation, I may not be able to go all, but my whole idea is to show you some details so that if you got interested, at least you can capture that paper and then work on it further and look into the details. Okay. So now, what are the typical routes that are utilized when we talk about hydrogen production from solar route? See, the famous photovoltaic solar PV hydrogen production system route, I'll show you. If you give me a few minutes, I have a journal paper I'm going to display. So in a typical, like how we produce the electricity that is utilized through electrolysis, which I'm going to show, which you might have heard already about some details. If not, this is an existing. Okay. So the solar PV hydrogen production route, that's one of the route. Then the thermal, we capture the solar thermal energy, utilize it to produce hydrogen. Now the question is whether you are talking about PV route hydrogen production system, thermal route hydrogen production system, we conduct a lot of details, that means in research, So when you are doing research in terms of analysis and details, whether you are using energy analysis route these days, this is what one of the my intention of putting this title, putting this paper to show you is even in hydrogen production systems, any system that you take, people are not restricting their research, their performances, their investigations, their experimentation, whichever way you name it, please. It is not restricted to only energy side of details. Now it is extended to exergy, as at least you got some idea through my first lecture what exergy and why it is important. So people are doing a lot on exergy analysis, exergy efficiencies. I will just show you some details from one of the article too. So the article that I am going to display is one of the paper done by a postdoc. Just give me a second. As I said, for the time limitation, I could not. If I had taken only this paper, I could have discussed one lecture that doesn't benefit much. Okay. So you can see here, as I was saying, I will be emailing this paper to Professor Kumar. So the PV hydrogen production via electrolysis, this is a very, very well established route, but there are some comments. If you have any questions for this one, please hold them till middle of my lecture, then I will open the room. So this particular table tries to give you a lot of details on the PV electrical and thermal route of hydrogen production. So now look here, this is a typical system. We have solar energy, we have a PV panel, then we have electrolyzer. So you might have heard about these electrolyzer, even few presentations. If not, you go to any chemistry book, any standard book that gives you. So now this is where we have hydrogen production. So there is, this is the way typically we produce. All those details are given here, these equations, the electrical energy requirement, all those. Now that is not about that one. I have few things that I'll point out. As I said, I'll go through. Now if we go again, the thermal route, the concentrated solar thermal energy production, these details are given, but question is, let me show you the figure, please. Oh, did I miss the figure? Yeah, just give me a second. I'll just show you the, yes. So you can see here, in a typical thermal, okay, because we can't use that high temperatures the way it is. We don't have that availability. See, these are concentrating collectors. This is a typical engine, and we have the electricity generator. Then we have electrolyzer. So again, these type of systems are analyzed a lot. So even in this paper, you do have the details. So as I said, my objective here in this lecture is not to go over each detail about this PV route of hydrogen production, thermal route of hydrogen production using solar energy. I just wanted to give you the overall broader view. So now if we have the way to approach them, these are all given here. So including, as I was saying you, what are the steps that are involved depending on whether we are going through thermal route. So if it is solar energy, if it is a thermal route, we have a solar thermal collector system, energy storage, the engines, generators, then electrolyzer to solar energy, hydrogen, solar hydrogen. Then you have PV, all this route to the hydrogen. So then the thing here in this particular work, the energy exergy efficiencies are analyzed using different combinations for the systems. Now, the thing that if you notice, that electrolysis, as I said, it is going to come in one of the slide. There are so many details here. I'll show you typical efficiencies. You just notice them. Just keep in mind when we go there, I'll show you their efficiencies are very low. The solar systems, the way the hydrogen is generated, even some details are given here. Okay, so this paper, it goes on trying to give you the my whole idea is, as I'm telling you, my whole idea is to show you through solar route, through the utilizing solar energy, whether it is a PV, whether it is a thermal route, how we can produce hydrogen. Now let me continue with my Okay, so if I continue to the part, so I try to show you what typically through the solar energy route, how hydrogen can be produced, where research is conducted, why we conduct research, what we need to do further, that I will highlight as I go through. Now let me go through. As I said, I wanted to show you the advances and developments. Now I am going to focus on some details on where is the current hydrogen production, where it is consumed, and what is the details, different technologies used. Again, not everything can be explained given the time limitation. So you can see I am focusing with reference to the different fuels where you are going to see fossil fuels too. There are different hydrogen production approaches which I will show you. I mean, it's not just the solar or thermal that has very limited at this stage the contribution, whether through gasification route or a different way of including incorporating the capture. So these different systems are highlighted here. My focus will I will try to focus on few things. Pay attention. This on the screen it could be small, but here it tries to give you an idea about hydrogen production scenario, the supply and demand. See, so these are where we have different sources that are helping to produce hydrogen. There are different applications. Please notice it, whether it is in transportation sector, if there is a hydrogen available, is a lot of opportunity. Even people talk a lot about fuel cells, vehicles, all those. Now, we are not trying to criticize. I'm not trying to say something on one or the other. The whole idea I'm trying to show you is this is the typical hydrogen production side of it, whether it is a PV, hydro, nuclear, utilizing natural gas, coal, all combinations, where the hydrogen is consumed, what applications, from transportation to industries to buildings to, because there are a lot of energy requirements. So meaning is there is a lot of demand for hydrogen if hydrogen can be produced. The question comes down how hydrogen is produced, what is the source of that hydrogen produced, are there any consequences, are there any issues, then through research how do we address those issues. That's where tremendous is. So all the story that is written here, these points, that's what it highlights. So now let me pay attention to this slide. Particularly there are 6 to 8 slides which I will be highlighting. I want you people to pay attention. Sometime don't worry, or if you say that, oh, what is there in it, this just is a pie diagram or round diagram or some other diagram with some details. Sometimes a diagram gives us a lot of opportunity to do research ideas, to write a research proposal, to get a research project, to work on it. So don't ignore them. They're saying that, oh, it is some number, some graph, some table. No. Sometimes one table is enough to discuss for 1 hour. 1 hour. Now, if you notice this one, that's what I was saying you. So one way the organizers gave me the last lecture of this to show you the developments on hydrogen. So last 5 days, you might have seen a lot of details. If you have noticed here, this is more or less the current hydrogen production of the globe with a little variation, a few percentage points at the most, this way, that way. So what I want you to notice here is if you take this to be 100%, please, if you take this to be 100%, the diagram, try to notice, see the current hydrogen production in the globe, close to 47% of hydrogen is produced using natural gas. We will see, I will talk about the pros and cons of this approach in a minute. Okay, again with research focus. Now look here, the other two sides, if you notice, please, coal is contributing a good chunk in hydrogen production. Oil is producing. Now, as I already said the sentence, I am not trying to say anything on any side, but the reality is when you listen to sometimes speakers, we stress too much about, oh, clean hydrogen, electrolysis is great. This is how it should be produced. This, sometimes any statement that is made has to be supported with numbers. In engineering, we can't make statements and then I cannot support that statement if I don't have a backup, if I don't have a theory, if I don't have an equation, if I don't have a number to support my statement. Now look here, the reality is if this is the 100% hydrogen production in the globe, what people typically highlight a lot in lot discussions is they go on talking about electrolysis is good, it is the best way to produce hydrogen. Yes, the way to produce hydrogen is the best route through electrolysis because it doesn't involve much of issues. But the question is, the amount of hydrogen that is produced in the globe even today is typically 4 to 5% through electrolysis. Then from where rest of the hydrogen is produced? Again, the same story, it goes back as I showed in my lecture one. It is the traditional fuels which are supporting, which are supplying, or which are producing the hydrogen. So half of it is almost coming from natural gas, rest coming from coal and oil. So what it shows you is on two sides, if we are worried a lot about the impacts of utilization of these fuels in hydrogen production, then we need to know what those issues are. Then we need to frame them as a research projects or objectives to work in the long run to address them, or bring, see this small, I cannot highlight too much here, this small arc whatever you see on this diagram, we need to increase this so much that these three gates almost virtually exist, we remove from them or we make them small. It is not going to happen overnight, I'm telling you. To say a nice sentence may look good, but reality may be completely different. So the electrolysis, the amount of hydrogen produced is even very, very small when you compare. So that means there is a lot opportunity room, which we will see. And this figure just gives an idea about, sometimes when you say, oh, where this hydrogen is utilized. So, I mean, because this is a part of a PDF postdoctoral fellow work. For Canada, the example is shown how in different industries hydrogen is utilized. So from chemical to these to oils to, so this is a typical utilization pattern. Okay, for any country we can represent it. The question is this one. So the hydrogen that is produced is coming from sources, and the electrolysis contribution at this stage is small. We will see the reasons, we will see where the scope is, all those stories. As you can see from this, the solid fuels, you saw there, even coal is utilized. So if you look into the fossil fuels, which are typically classified as non-renewable, even today, I'm telling you, please, even today, overall, is not about just hydrogen. Overall, in energy mix of the globe, leaving few exceptional countries like Middle East, few countries, or France, like where a lot of nuclear contributes almost 80 or 83%, leaving exceptional countries, typically on a basis of the globe, majority they still contribute. So then we have other biomass or these ones which are classified still as renewables and inorganic. So there is a room to utilize them. There is a room even to produce hydrogen. Okay, so now this is the end product we are looking. This is where we have, so there are different routes. That's what I was showing you in one of my earlier slide, different technologies that are available to produce hydrogen. I mean, given the time, I'm trying to focus on the developments and opportunities and scope. So if we see this one slide, I know the letters could be small because it is scanned and put it here. Pay attention, please. So if you are going to pay attention, if you recollect this, always you need to keep this one diagram in mind, these numbers, because a lot of my comments will go in comparing with that. Now look here. So it is trying to give you the comparison of hydrogen production by different means through a research study. Okay. So now we see, I already said, uh, almost close to 47% is produced through steam methane reforming, a massive approach, because that SMR, what they call, is one of the highly efficient approach to produce hydrogen at very, very cheaper rate, utilizing natural gas, because natural gas is still available in plenty. lot of the countries are discovering new natural gas resources. Even in India, we find a lot of gas reserves. And one way, good or bad, it is reality. Slowly as we are warming up, the planet is warming up, a lot of areas are being liberated from ice in many countries, so they are finding a lot of natural gas in those lands which are accessible now. So the story is, with the time we may be having more natural gas reserves added rather than decreasing. It is the other way that is going. That means we want to utilize, we can't ignore them. So if you see here, the typical efficiency range is given here, and observe, this is represented in US dollars per gigajoule. What my objective here is to show you, if this is the natural gas, steam methane reforming, the efficiency range, the cost of the hydrogen that is produced. Then this is for biomass coal through a route called gasification, efficiency range, the cost. Again, notice it. Like that, look here. This is what I want you to focus. My objective here is to highlight few things, show you the methods research is going on, and to show you where plenty of research areas that are available in hydrogen so that we can contribute in future. So if you see electrolysis, uh, this is what I told you. A lot of times people only go on talking about this and highlighting it only. Okay, so if you look at that electrolysis, through water splitting, look here, the typical efficiency range, look the cost. If you have noticed in the diagram that I showed you earlier, electrolysis contribution is typically 4 to 5%. Now the question is, even if you look at the cost wise, when you compare, I'm not saying this is great, no, don't mistake my words. I am showing you where the contribution is present, hydrogen coming from, the typical processes, their efficiency ranges, and the cost range. So that means quite expensive. So it shows you few things. There is a room for us to do research even in electrolysis way to figure out how can efficiency be improved, how can cost be brought down, because ultimately these are the driving factors. Similarly here, these numbers look favorable. What are the issues associated with this approach? If you take natural gas, if you take hydrogen production, then, oh, this looks to be very great, half of it is coming almost from natural gas. Then why people criticize natural gas? What issues are associated with natural gas? Then can we address them so that this can become further in the stream of hydrogen production? So this is a table. Just if you look as a table, these are numbers. If you look only as a numbers, if you as a researcher, if you are looking at this table, you are going to look that there are plenty of opportunities depending on whichever one you are going to pick and what research you can do. That is where that the paper that I had, whatever the paper I was trying to show you on solar, why people are working these days so much, why people are working these days so much. Solar is renewable, solar is friendly, solar is, I mean nothing, no issues, clean. Now question is how to improve these things, and any little improvement. I am not saying we are not going to bring down suddenly next year everything to 5 or 4 are comparable to this. It is a long way, but there is a benefit in going in that long way. So that is where, I mean, if somebody is planning to work on solar for PhD or planning to submit a project, there's a lot room, there's a lot opportunity for success, lot it is. So this table, uh, keep in mind, because as I go and highlight few of the details, you are going to see later the thing. Okay, so let's continue. Please take a look. I mean, it gives again an idea. So the idea here is different things, so things are compared here. So you have here a total cost comparison of typical hydrogen technologies. So these are represented in a abbreviated way, in a simple way. So if you look here, there is a SMR, that is natural gas based one, or coal or other things. And then you do see here, like with the biomass and coal. So you can see again here clearly that whatever the electrolysis which I was trying to show you in the previous slide here, you can see here, these are all coming through research. So you can see the electrolysis, which is the clean way to produce hydrogen. That means we use electricity there. We split water into hydrogen and oxygen. And now you look at that cost side of it. So what it tells you is, though it is a well-established approach, there's a lot of research that needs to be done in a way to make it more economical. If a day comes where, imagine for a moment, I know I'm not trying to give you a short answer, no, I won't do. This is where we have, say, natural gas where hydrogen is produced. This is where we are trying to produce electrolysis, through electrolysis, hydrogen production. Now, the question, if somebody says that I came up with a system where even I can capture CO2 from natural gas way of hydrogen production, so that way it is as clean as solar or wind or biomass, then if this is going to be very, very expensive, then the customer will prefer this only, not the costly one. This is what I told you. At the end of the day in engineering, economics matters a lot. Okay. If you put apple to apple comparison, I'm not, we cannot compare orange with apple and then say and conclude, then it becomes a biased conclusion or biased approach. But if you are putting on the same scale, same comparison, if one is going to be better than other, then why people will only go this? So there is a lot of room to work on with every side of it. Okay. So let me show you the other one. So this showed you on a cost side of comparison. Please look here. So each one has their own issues. So if you look at, the CO2 impact, the CO2 that is produced when we are talking about hydrogen production from different means. So here, this scale gives you, please. It tries to give you here amount of CO2 in kilograms per gigajoule of hydrogen production using different means. These all come from what you call trusted sources, from references. So if you are looking at, because natural gas, which is most of it is methane, when we use those steam methane reforming, what they call is one of the highly efficient. You saw the efficiency range; it was very high, in 65 to 75% range. So there is a carbon dioxide production that is associated. Now, if you look here with coal, you can see here, please. If you saw in hydrogen production, coal did contribute a good chunk. So if you are trying to bring now CO2, now we are trying to compare them, on the issue side of it or emission side of it. So you do see the CO2 emission that is associated much higher. Like that, you have CO2. Now, sometimes I think some of these tables, they try to throw you a lot of information. This is what I'm telling you. Sometimes you can pick only 2 tables, you can go on talking for 1 hour, even if you are an expert talking somewhere. So now look here, this is one of the things that highlights in a big way this color. This tries to show you here electrolysis, coal. I just want to highlight some things. If suppose power is produced, electric power is produced through coal, and somebody using that power to generate hydrogen through electrolysis. So if they say that this is the best way to do, but from where that power is coming also matters. So that's what it is trying to highlight you. What will be the CO2 impact that it will have? So sometimes we should not simply go by electrolysis saying that this is the splitting of hydrogen, water into hydrogen and oxygen using electricity. From where that electricity is produced also matters. That has to be specified. If somebody doesn't specify, goes on highlighting only electrolysis, so meaning is something is not given fully. Then comes really, as you can see at the bottom here, please, depending on what you are talking, whether you are talking solar, wind, yes, they don't bring any emissions. So the overall, this one tries to throw you the cost side of details. This one tries to show you the emission side of the details. Put together, these 2 tables will give you an idea about different hydrogen production technologies or systems at this stage. where they stand, what advantages they have, what issues they have, what problems they have, and what opportunities they provide. This is what I'm telling you. They provide a lot of opportunities. Maybe few of them I will highlight as I will go through. Any questions or any comments at this stage, please? Okay. If I don't hear, I will continue. Now look this one. This, I think, the work that was done by the postdoc, there was a comparison up to 2020. Later people can do. It's a very similar sort of comparison. So you can see here, I mean, the hydrogen typical comparisons are done with various options, because as you can see, when you are looking at these fuels, when it comes to natural gas or coal or biomass, biomass is carbon neutral, so particularly natural gas and coal, even oil, there is a CO2 that is associated. So this one tries to give you an idea. Suppose if we are going to have systems with these combinations, where do they stand with reference to the efficiencies or cost or comparison? So you can see here, there are different parameters, please. Comparison of hydrogen production for different feedstock. So these parameters are shown on one side. So efficiency to investment to, feedstock cost to hydrogen production cost, and typical, when the work was done, it was taken for 2020 comparison. Okay, so where do it stands? Okay, so if you take natural gas, that is where SMR, steam methane reforming, which is highly efficient process. So you can see typically its efficiency very high. It's almost 80%. Then the details are given here. These are in euros. This reference comes from the Europe. Okay. So now you can see here what the hydrogen production costs are and where it stands on a comparative scale in 2020. Now you can see, this is what I was telling you. The future is headed, they cannot be used without considering CO2. CO2 has to be brought into picture. If we are going to bring CO2 into picture, that means the natural gas to hydrogen production, which is SMR, which contributes almost 47% in today's market. If we are going to consider the CO2 capture into it, there are many ways to capture. There is where people are doing a lot of research now. So the CO2 capture, this is what I'm telling you. If we can capture CO2 from natural gas, then it is as clean as comparison as to solar and wind hydrogen production. So again here, a typical efficiency range, the cost that is associated, because you are trying to involve CO2 capture, cost will go up, please. And then typically when you see it goes up, but still it's a very, very favorable. So you can see the values that are listed here. Now, coal also contributes in hydrogen production. Look, coal to hydrogen, where it stands with percentage, the efficiency, its economics, and unit cost. So when you really see this, even it is comparable to natural gas. Now, if we bring hydrogen from coal production, through coal with CO2 capture, you can see actually here efficiency improves, and these are the cost comparisons. And this biomass anyways consider carbon neutral. So the whole point of this table or this research or this comparison, that was taken by the PDF to develop numbers for comparison purpose. So the whole idea is, even if we incorporate CO2 capture into these systems, please observe my wording or statement, please. Even if we incorporate, if we develop technologies and mechanisms to capture CO2, the natural gas or coal, when you look at their efficiencies, when you look at their cost details, these are comparable, or even the way the electrolysis approach stands today, these are even more economical. Then in the question, as I was telling to you, in the market, economics also dominates. See, nobody is going to buy some product If you price it at very high when the product is available on the other side at a cheaper rate for same comparison performance and parameters. So that means a very interesting points and for research purpose too. Okay, let me show you some slides I may run if I have still I'm fine on time. So let us see. Now we know, I mean, you have an idea about what gasification is. When you have a solid fuel, you feed, I mean, supply oxygen or steam or in a way that partial combustion followed by reactions that leads to syngas and cleaning and separation. These are available, the details. So it tries to give you an idea. So we clean the gas, we can run what you call the electricity, we can produce hydrogen. I'm going to show a system where I'll be spending good chunk of time in explaining. So this is a typical a details that gives you an idea about gasification, the approach, that conversion technology for producing power or multi-fuels or synthesis gas or hydrogen. The whole story is okay. I think I'll just show you some of them, but my focus is, as I said, to explain in a way where the research opportunities and the developments are happening so that a piece or system can be taken, whether you or me, we can work, we can produce papers, research advances, get projects. So ultimately, your FDP should benefit you at least some way or the other. That's where I'm trying to put some details or focus on some details. So this is a typical one. It shows you when it comes to the to a typical system of production. If you have, let us say, coal, we have a gasification system, whether we are supplying oxygen, air, steam, there are different gasification routes, technologies. Then we have synthesis gas, we clean it. This is the gas cleaning approach. Then there will be particulates we need to remove, then finally leading to hydrogen production, hydrogen utilization. There are details. Now the question is, how can we advance them further? How can we improve their efficiencies? How can we even incorporate? If you have noticed one of the slides earlier, how can we incorporate CO2 capture? The key, I'm telling you, the key with coal, natural gas, oil, which are contributing close to 90%. Let me put electrolysis even today, please. You go and refer after my lecture. I think it stands at 5% in contribution or 6. So that means still 90% is coming from them. So this is where we want to reduce or we want to modify them. Modify them means not talking about just hydrogen production. Question is how to incorporate carbon dioxide issue, how to think about capturing carbon dioxide, what to do with the carbon dioxide afterwards, because it's a huge quantities. So can we grow algae? Can we grow something? So there are many, everything is a question mark, is a research opportunity or opportunity to get a project and work on it. So let me spend some time. I'm going to spend a little chunk of time here because this is a one nice diagram, one nice picture, but with huge opportunities, not only for you, for me, for any researcher, or for any even investor, government agencies, because this is where a lot of scope or details is. So please look here. I mean, whenever you see a system, I told you, these are all multi-generation systems. Multi-generation systems, integrated energy systems, you have many components tied together to produce power or benefits or products together. So this is where you are seeing is a typical gasifier piece, a gasification system. So the feedstock is shown here. And typically this, we are talking about solid fuels. If it's a natural gas, steam methane reforming, the only question there we have is CO2 issue. So if we can figure out how to capture CO2, that there is a way to improve it. So now we are talking about coal or biomass. So you take a coal, suppose here. So if this is a gasifier, please look. So that means we supply steam or air, depending on, I told you, there are many different routes. The details are available. You go to a typical advanced power plant book or gasification books, we find details. So see, this is here, it shows you, depending on whether we supply oxygen, air, steam, or combination. So inside, the gasification reactions happen. Partial combustion followed by reactions, then unwanted solid byproducts are removed. It shows you here. Then comes next the syngas. It contains a lot of particles, other things. So the cleaning happens. There are systems. There are systems. There are people who do research. There are people as advances happen with materials and cleaning systems. Even these components are getting improved. So that means you have here cleaning systems that you see here. Then afterwards, please observe the syngas now undergoes different steps. So that means something is taken for as a fuels, so the gas as it goes. So because the way those reactions are, if you have noticed in one of the earlier slides, there is a hydrogen component. So that hydrogen is separated. So then we do have, notice here, so the way it is, there is a gas with some calorific value which can be estimated through chemistry approach. So we can have a gas cycle. See, look here. As I said, I will be taking time to explain. So you can see here, this is the gas turbine system. So you have a, compressor system. This is the air, the compressed air. So this is the combustion chamber. This is the gas turbine. It is shown here a simple gas turbine. Reality is, as I showed, we use multi-stage gas turbines with reheat combustions to improve the performance. So then you have the generator where power is produced. So that means there is a gas cycle that is producing power. Then this is the waste heat. Remember, I told you, we don't use old turbines. We use modern, latest, advanced gas turbines, which operate at higher temperatures, higher pressure ratios. The waste heat coming from the temperature of the gas is coming from the gas turbine after exhaust is so high from second law. We try to utilize this in a heat recovery steam generator to produce steam, run a steam cycle. See, even this is a multi-stage steam turbine. Then the generator, the stores, the other components. So the story is, we have a gas cycle utilizing the syngas after cleaning to generate power. We have a steam cycle. So that means there is a power generated in a combined cycle mode. We have a gasification system. We have a gas cleaning. We are trying to produce some chemicals. So we are trying to separate hydrogen. Even you can incorporate here fuel cell. Please observe. So you have hydrogen production, power production using multi means. Now to the extent, now if you can notice, those letters are small because this diagram has so many components. So letters are obviously represented in a small way. If you look here, it has a carbon capture in this system, please. And this is written as sequestration. So meaning is, what to do with the CO2 that is captured is different. Do you store it? Do you throw it in the underground, compress and send it into the underground? There are issues. Can we grow algae so that biodiesel can be produced? What to do with is a question mark, a research opportunity. But the overall system, as I am telling you, please observe this system. The way this system is, this is a typical multi-generation energy system involving a fuel. Say example, you take coal as an example. With gasification followed by so many components, with power generation, fuel production option, hydrogen production option, with CO2 capture option, then that hydrogen, that's what I'm telling you, we are in big demand for hydrogen. Already this coal is producing 19% in the current market. If that same coal, if it is in future, let us say it could be 5 or 10, whatever the time period it is, if research is done, technology is developed, let us imagine one day we have this type of system into real commercial stage where things are produced, where hydrogen is coming in a big way, CO2 is captured. The economics of it, I'm not commenting, because unless we do everything, compare apple to apple, then we know what the cost of the hydrogen per unit or per gigajoule. Even in one of the slides I showed you earlier, even with CO2 capture, there you saw that its cost is comparable. Even with natural gas, its cost is much comparable even to electrolysis, even if that electricity is produced through solar or through nuclear, because those are pollution free or emissions free. So the thing is, that means it shows a huge opportunity to produce multi things like this and then lead to what you call better side of it. Now, I think I will probably, I know nobody is responding. At least I will hold here for a few minutes to see your comments and any questions that you have. If you see a system like this, if we can have this system, let us say research is done in a big way, let us say in 5-10 years, we have systems like this that are going to utilize coal, produce multi-generation things from electricity to fuels to hydrogen to including CO2 capture mechanism. There is, in some plants, there are, I think when you read literature, you will see there are some power plants in some countries, particularly in US. They are trying to capture CO2 from a big power plant as such. Okay, a coal-based power plant or a fossil fuel-based power plant, produce using that CO2, produce algae and then produce biodiesel, look into its overall economics. So what I am trying to say is if there is a way to capture and utilize or take care of CO2, let me put that word, then if you look this system, though it is, people say that coal is a dirty fuel, this system, which is trying to utilize the most vast available dirty fuel in the globe, if you look with incorporation of all these, how do you see this system when you compare with wind or solar or any other clean side of energy systems? Can I know any comment from any one of you, please? Any questions, comments? Come on, I'm only speaking. How do you see this? So if you can incorporate all these into the system, if we develop technology where this is going to be commercial, available and ready to use, then I'm not commenting on economics now, because when you don't have numbers, never comment. You can only give idea, trend, or how it can look like. As an engineer, as a researcher, as a professor, you or me, we never comment this is like this when I don't have something to back up. So if we can have everything and if we have economics available, if you are trying to compare this system as a system which, let us say, is operating on coal, trying to produce all these things, if I compare this with wind and solar, I will say this is as good as coal, as good as wind, as good as solar. When I don't have any CO2 issue from here, this is as sustainable as solar, as sustainable as wind. What is the wrong? Having a system like this, if economics is favorable, that is where one side, if you are a researcher, if you are a professor, you are looking, not only, I'm not saying we need to work on solar, we need to work on how to produce hydrogen from wind, again, that is through electrolysis route only. Produce electricity first, then use the electrolysis route, produce hydrogen. So, but if you see here, there is so much from gasification to gas cleaning to multi-utilization to performance to emissions to hydrogen separation to hydrogen estimation to so CO2 separation to CO2 capture utilization to so whatever you name it, there are so many areas where each piece could be a research project and people are working. I'm not saying just like in an imagination way, people are working. So there's a lot opportunity to do research. So this is one of the slide, apart from some tables and some comparison of technologies I showed you, I wanted to highlight. I mean, a takeaway from this presentation, at least one of the thing is this benefits you to think about some research topics or projects or thing. Okay, now let me continue because I have some more material. I have to follow the time. Okay, I think I am on time. Yes, please. Anybody has any question? Okay. Yes, please.
Good evening, sir.
Yes.
Hello, good evening, sir. I am Ram Manohar Pandey from Sri Ram Polytechnic, Bihar.
Oh, good. Please go ahead.
What I take away from the figure you just detailed about, and it is very much encouraging that nothing
Yes.
in nature is type of wastage. We can focus on, rather from devising new technologies, we can focus on existing technologies to be sustainable and to be
Yes.
useful. That is
Yes.
what you are trying to say, sir.
Yes. Yes. You put it in a very nice way too. You added some more information to my details.
Yes, sir.
Any other comments, questions?
அந்த கலர் இந்த ஒயிட் இருக்குல்ல டிபார்ட்மெண்ட் ஹெச்ஓடிக்கு அது மாதிரி எல்லோ கலர் திறந்து பார்த்தா நாளைக்கு வந்து வேலை போட்டுருவா. நாளைக்கு வரணும். திங்கக்கிழமை இன்ஸ்பெக்ஷனா அந்த கிளாஸ்லயும் ஹெச்ஓ டீன் சார் மீட்டிங்லயும் போயிடுச்சு.
எக்ஸ்கியூஸ் மீ.
அவங்க வந்து வெளியே இருந்து வருவாங்க. நானும் அதை திறந்தது இல்லை. அது பிளாக்.
Excuse me, somebody is speaking.
நம்பர் படி 52% அப்படி வரிசையா போகும். நம்பரே கிடையாதுன்னு.
Hello. Okay, any other questions? Okay, if not, I will continue. Good. Whoever the participant from Bihar, the institute. So the point that you see here is, I will just take two or 3 minutes to highlight little. The reason why I was highlighting so much 3 countries, if you noticed in my lecture 1 when I started, China, India, USA. Now population wise, I should put the other way: India, China, USA. These are the 3 big populated countries in the globe. The surprising thing, go and check afterwards after my lecture. These 3 countries, it so happens, they have vast amount of reserves of particularly coal, and not only that, other fossil fuels. They also utilize in a big way. When you look the energy mix of USA, major chunk comes from coal, oil, and natural gas. So in India, I know we have less natural gas, but still we have a lot of coal. China has so much, they use a lot. Though there's effort on solar or wind or other renewables. So the point is, as I tried to say, not by my own, through research, through the literature, where through supporting numbers, as one of the participant was highlighting, there is a need to do research. This, I'm not saying this is the only way you need to do research. This system, the way the components are proposed here, gives you an idea. So we need to find a way to utilize these coal and natural gas particularly in a way that we can produce power, hydrogen in a multi-generation way with virtually no CO2 issue. If we can find a capture mechanism, yes, it is not cost, it is not difficult, please. CO2 can be captured. Only question now, right now, is what to do with the CO2 is a big question. So there could be ways to utilize that. So that means then it becomes as clean as solar or wind. So there's a lot. So even this one figure, the information I put it has helped you. I think my part 2 of the lectures purpose why I prepared has served it. Anyway, we'll continue with the details. Now, I mean, you can notice in this diagram, as I said, I mean, lot of these reactions are self-explanatory, or once I email the paper, Professor Kumar will email you. So you can see here, the idea is, even with coal, when we are talking, here you saw only this route only, where coal, all the things are happening. The modification or a combination here is, even solar energy can be utilized partly, even though you are talking about coal or its utilization for multi-generation production or hydrogen production. So it is trying to utilize your solar energy through a different way, whether it's for gasification or for different routes. I know that diagram is small. Please look on the right side of this diagram. You see here, this is sun, the solar energy. So we have the solar source. Then our aim is, when you are talking about finally to produce hydrogen, you see the byproduct here, the hydrogen, there are different means, please. So you can have gasification, decomposition, many other routes, finally leading to hydrogen production. So Excuse me? Hello, somebody, you have to switch off your mic, please. So you can see here how solar energy can be brought again with the way I was discussing, or with even coal and hydrogen production. Utilizing that further reduces emissions because you are using solar energy for part of the process or part of the reactions in the system, which ultimately leading to hydrogen production. Okay, so this is again a sort of an idea, because I was stressing so much with CO2 capture. Some details are shown in these diagrams. I mean, how CO2 capture can be incorporated, because this is like a big opportunity, big room. And again, the steps are shown, and lot people are doing research. These are taken like from somebody worked for 8 months to develop some things. Just one figure or details are captured from there to show you where the things are headed. Okay, so this particular chart, if you look, it tries to summarize you many things. You can have a integrated systems to produce hydrogen. These are all where the things are headed for development. So this is what hydrogen, that's what we are looking, because we are talking, we want to use hydrogen. Yes, if you have a fuel cell based vehicle in a city, let's imagine a city in India. These days we talk a lot about in Delhi, lot pollution, smog, these, that, not only just because of the vehicles surrounding other thing. The question is, if the way the whole transportation is transformed or changed, that imagine for a moment it is all public transport, people are using only fuel cell based vehicles or some sort of a system. So that means where hydrogen is playing a role, then at least people will have clean air in the city, people will have less health problems, a lot other benefits. So here it shows you which energy source we are talking. This is our end product. Hydrogen is the end product. So you can see here, if you're talking coal, biomass, municipal solid waste, the route that can be taken finally to get to hydrogen. Or if you're talking about, coal alone, or if you're talking about agricultural residue, if it is available, there are some countries where it is a plenty, So organic waste or municipal solid waste. So the whole idea is, depending on the source, typically a lot of these are solid based, solid fuel based. Okay, so leading to hydrogen production side. So this is, the roots. So here it is shown as a part of an approach, but not every details are not known. This is where next some of my slides will show you. A lot of them are unanswered questions, challenges we need to address through research. So whichever one you consider, there could be some advances, there could be details available, but they are not the what you call the best or the efficient details or efficient approach or the system at this stage to produce hydrogen. So we need to do research to advance them, modify them, incorporate them, do some changes. So it goes on with so many details here and opportunities there. Okay, so now this is where it brings back to some of the things. There is a lot benefit, because these solid fuels, whether they are coal or municipal solid waste, other forms of waste, it is available a lot in many countries. Coal is available in plenty. Even other solid waste is available in plenty. If we can utilize, so we will address many issues. Also, we will benefit from it. So that means, in terms of feedstock availability, yes, it is available. And there are technologies being, now research is being done, there is a lot of improvement that is happening. So a stage will come, or there are some proven already, but they need a lot of improvements. There is an integration. What is the benefit? Because whenever you integrate, when you have multi-generation systems with multi-generation, always, I tell you, not only efficiency, performance, always cost favors. Whenever you are incorporating multi components into any systems, multi-generation benefits, the economics is always going to favor. And the hydrogen market, when you look at the hydrogen market, if you recollect the diagram, circle diagram where I showed you the 100% hydrogen, which produces how much from is around 4 to 5, remaining coming from others, that is natural gas, coal, and oil. Now, what the question is, hydrogen market is not every year, every day when you see people say that the market is, there's a lot, it is increasing. There's so much demand for hydrogen. But only thing is, are we able to produce? Are we able to supply that hydrogen? Then what way? This is where I told you there is a demand. Okay, so there is a lot of demand for large production, but it has to come in a way that it has to be environment friendly. That's where even if this SMR natural gas is going to continue, people are going to look into CO2 capture. It's not going to be an idea earlier. Now it's going to be a part of it. People are working so that it can be incorporated. So it shows you a lot of the benefits, opportunities that are available, not on the renewable side of hydrogen production, even with coal, which people consider. I am using the word, I think somewhere it comes in one of my slide. People don't put the reality into reality side of the picture. We call coal as a dirty fuel, but surprising that dirty fuel is what is feeding us, which is able to survive us. If you imagine for a moment in India and China and USA, if we remove coal just like that today, I think probably one third of the countries, one third of each country will be in dark. There is no way to have power, okay, overnight. Okay, so now there are a lot of challenges. Let me put this way, those challenges are research opportunities. That's what part of the thing is. How can we integrate those systems? I showed you one of the figure with so many things: system integration, integrating components, integrating the multi-generation products, conducting research, coming up with what you call a best way of configuration. I can draw one figure the way I want, you can draw one figure. So you and me, we cannot say that this is good, that is good. We need to do what you call the engineering analysis. And these days, that engineering analysis even involves second law. Without second law, we don't do any analysis, XSG. So we need to have system integration, analysis. We need to look into environmental side of it to the extent these days, capturing CO2. And please look, I do have one more piece of, one more paper, which I will highlight a few details in explanation. Location. See, sometimes location matters. See, you can't take a big system, which I showed you, where coal is a fuel. You are not going to locate next to a big city, whether it's Hyderabad or whether it is in Toronto or whether it is in New York. So there are environmental impacts unless CO2 capture is incorporated. What I am saying is there will be location issues. Sometimes urban centers may not favor, because near urban, land could be very expensive. So land becomes part of economics of any system. Even if you take solar, where land is virtually zero, its economics is going to be different. If you are going to put next to a city where land is very expensive, solar economics for the same technology will go completely off, completely different. So, and sometimes, yeah, location, then you do see. So this is important. So, I mean, please look the last sentence. I think I will try to read this sentence even. Lack of awareness on clean technologies. Sometimes what happens is, what we say, sometimes people just take it very quickly. So the public and the media in general, if the way they perceive is that, oh, if you say it is a coal plant, oh, it is a dirty plant. But you need to see the details, what way it is generating power, where the emissions stand per unit power generation, or does it have CO2 capture mechanism. So the public and the media in general, they think coal as a dirty fuel based on just whatever the perception or misguided information they have it. So lot of times, let me tell you, because I got opportunity here through this sentence. Nowadays, we as professors or in engineering, we not only do developing codes to developing technologies to developing a lot of economic details of technologies too. These days, you do find, I'm telling you, you do find great researchers or scientists or professors working on some what you call policy aspects of something. policy aspects, catch my word. Suppose, imagine, I'm not here to criticize any system or anyone. Suppose if there is a big electricity system or board, somebody is sitting who doesn't have any idea about the technology or advances or developments. Even if there are great engineers, scientists below working in different roles, try to convince, if the deciding authority is not in a position to understand even, then what sort of changes will you expect? So that's why sometimes, I mean, people need to know the details, benefits. I'm not saying they all have to be engineers or scientists or researchers, but they need to have a minimum knowledge. So that way, that makes a difference. This is where sometimes you see in some countries, sometimes there are issues or there are bottlenecks because somebody sitting on the top thinks in a different way, doesn't know, so they don't take it that way. Some countries take on a faster route. That's why sometimes even technology is available. Why some country doesn't benefit, why some country benefits, it is not because of technology issue, it is not because of researcher or professor or student issue, it is not about second law issue, it is issue with the people who are not in the right positions. So sometimes for key areas, key sectors, people with some background in the sector should be there in those locations. That way, the technology advances, benefits can be utilized. Otherwise, technology will be there on one side, bottlenecks will continue, and it doesn't help to solve the problems. No, okay. So let us. Yes, this is my another piece, very interesting one for you people, those who are interested, thinking about, you know, doing not only just hydrogen research, not only energy research, engineering research, even if you are trying to look into how can I look onto multiple side of any technology or development or issue. Okay, so this is basically comes from a journal paper which I am going to display in 1 second, please. Sustainability of hydrogen production from solid fuels. As I was saying, you couple of my slides showed you solid fuels have a big role to play in hydrogen production. Then what is that? Because these days everything is related to sustainability. So there are people who are doing research to assess them. So this sustainability assessment methodologies, the indicators, which I have paper, again, this particular paper too, I will email, okay, Professor Kumar, so that you all of you can get that copy. What is that methodology that is used to assess sustainability when we are talking about hydrogen production from solid fuels? Then what are those indicators? Because they have to be compared with renewables, that is solar wind, which everybody says is the best way to utilize. Then this is where the linking. Then there are some ecological indicators. I'll show you. I'll try to read them, only headlines. Okay. Then what about sociological indicators? What are the technological indicators? See, don't think sometime I developed or you developed a system configuration, technology, efficiency. That is not the end of it, please. These days I'm telling you, for any system in engineering, we need to look many sides of it. Those are what they are, from sustainability to ecological to technological to sociological to all the story has to continue. Okay. Now I'll put a paper again here just to give you an idea. Later you will be getting a copy of it. Just bear with me 1 minute. Okay, I mean, we were very fortunate, me and Professor Rosen. We had a student called Nirmal Vijay Gnana Prakasham. I mean, he's a great, he did PhD with me, but he was a great postdoc. He spent good amount of time with both of us. He has done so much work. That's where I took part of the pieces from this postdoc, also another postdoc. He has developed a system, which I'll be emailing this paper to, a methodology how to assess sustainability of hydrogen from different solid fuels. No, there is, I'm not saying it is everything it has in it, but it gave a sort of a mechanism where how can we develop certain indicators And how can we compare these indicators in a way that when you compare that with solar or wind, which are renewable, which are clean, where do they stand? Then what issues are there where they can be addressed further so that they can be brought to the same scale of comparison, apple to apple, not orange versus apple. So that is where the story is. So if you look here, whatever the thing that I was saying you people. So when it comes to the sustainable assessment methodology and indicators, so there is a methodology. The details are provided, and what are those indicators, which I will show you. Within then, how do we link them? So now, if you pay attention here, it is all given in a diagram here with details well described in the article or the paper. Okay, so we have here so many things. This is the sustainability. See, we have from economy to technology to environment to ecology to human effort to sociology. No, at the time when this paper was published, I think there were very few with this approach. I say this contributes to something, a useful one. So now, if we are going to go, so if you look into, we go one by one. The way this diagram, I'll just show you. If you are wondering what are these ecological indicators one has to consider later on, once I put some brief information, if you have questions, comments, we'll have interaction. So what these ecological indicators, if you see it, one has to consider the availability, okay? And then because you are looking at something, and then adaptability, okay? And then environmental capacity, and it goes on. Timelines, material rate, energy rate, so pollution, location, all these things. Then, if you are wondering, what are the sociological indicators? So you can see the economics, policy, human resources, public opinion. This is very important. And the environmental obligations. Now this is becoming, I don't know if you people have noticed or not, 20-30 years before, many countries did not had many environmental side of obligations. And that is how sometimes, maybe I take a minute here just to throw you good information. This whole energy sector, or the whole thing that we are talking, hydrogen is part of energy sector. There's a big interesting developments. So when you see industrial revolution, it began in 1700s. Then coal came in a big way, machines came in big way in England. Then what happened? The machines helped to produce a lot. Then they sold goods, they got a lot of money, their lifestyle has changed, improved. So in the process it went on. Late in 1900s, I think, then they saw in Europe acid rain, because they were using so much of coal. There were sulfuric gases, when you burn nitric oxides, sulfur oxides, they react with water drop, leading sulfuric acid, nitric acid rain. Then technologies were developed in 70s, 80s, 90s. We can address acid rain issue. But later you will be wondering, CO2 was not an issue. CO2 became an issue from last 30-40 years. We are talking a lot about it. So like that, what I am saying is many countries never had environmental side of thinking or what environmental issues it will. But now more or less every country in the globe is becoming part of environmental obligation. Oh, these are the issues we need to address. Otherwise we will have. So sometimes you do see with the timelines, what I am trying to say is something which we don't consider, we try to consider. Why? Because it has an impact. It hurts us. It damages us. See, nowadays you see. So like that, there are, living standards, I mean, or maybe, again, I got opportunity here. Maybe I'll speak a minute or two. Some countries have where they use too much energy. Sometimes they may waste also. But the question here is, who pays is different. But when energy is produced, when it is utilized, depending on from which source it is coming, there is an environmental obligation. If coal or natural gas, oil is used, if you take a case where somebody is rich, goes for shopping just to get vegetables one time in a day, goes to get milk next day, or goes makes 2 trips in the same day, if that person has a planned approach, or the family has a planned approach, if they make all their list, go in a week, get all the things, what I am saying is they make only 1 trip to a shop, they burn certain amount of fuel, they emit certain amount of emissions compared to making 7-8 trips because they have money, they can afford. But is it good for the globe? Is it good for the other people? No. So that is what I am sometimes I'm saying you, in a technology, when we compare efficiencies, when we do a lot of analysis, we only talk about this efficiency, this parameter, this temperature, that pressure ratio, this hydrogen, that. But we need to incorporate, in a nutshell, many aspects which are part of the system, part of the problem, part of the solution too. So human and future developments, what I mean is sometimes, okay, oh, this one word came. So try to notice this one, lobbying. Sometimes what happens is in countries, I'm not naming any country, any government or anything. Sometimes you do see lobbying also has a big influence. Sometimes some technologies, some research in some areas are being slowed because of lobbying. Somebody says this is not worth, that is worth. So government gets influenced, the funding mechanism changes, that has an impact. So there were times when everybody said this is going to be happening, that is going to be happening, it may happen, may not happen. So there are so many factors that one has to consider. So you saw few: sociological, ecological. Now look, what are the technological side you need to consider when you are analyzing a system? I'm telling you, this paper tries to give you for hydrogen production from solid fuel, but in general, you can take any engineering system, you can do research the same way. What are the technological indicators that you need to consider? See, technological indicators help in assessing the knowledge, design, performance, and production aspects of an element or process. Here we are talking for hydrogen, so it talks about hydrogen, for hydrogen production from solid fuels. From engineering perspective, you can consider any system, as I'm telling you. Since it is a hydrogen here, then the question comes, the energy consumption. And these days, I'm telling you, even for you after these lectures, please think about second law, think about exergy, try to utilize for your own benefit to improve your own performance. I do every day for myself. Okay, so the role of exergy, role of efficiency, and the design modification, and research is part of it. That's how we advance. We will not here today without research. So the demonstration, all this goes on, commercialization, what impact it will have. So, and again, environmental. So then you compare the advantages and disadvantages. So the story, what I am trying to tell you, the story through this article is a methodology that is helping to look into all sides of an engineering system. In this case, it could be hydrogen production. So where you are not just looking only from efficiency, you are not looking only from cost and then trying to make conclusions and comments or something. Look from every aspect of it, from public to social side, to economic side, to ecology side, to environmental side, to technology side, to all these that will help. So a very what I call it is a very a good article. I mean, this will help. Now there is also example. I cannot go over each detail. This alone could have been my 1 hour lecture, but I did not choose not to talk on this paper alone. So there are examples given in this paper. So taking hydrogen production from coal and biomass, those indicators were developed. Whatever indicators I showed you here. Yes, please. We have some more minutes. I will be speaking another 8 minutes, then I'll give 10 minutes for interaction. Okay. So if we look here, so you have hydrogen production from 2 sources, that is solid fuels, coal and biomass. So it all given. So these are all estimated through the methodology, the ecological indicators, the sustainability indicators, social indicators, all those that goes on. And look here, this is, I think at that time, I don't think there was a representation of this approach, representing them in a way to make meaning all at once. Okay, so it details you all those things, and then it talks about even the coals, their sustainability. We call dirty fuel. No, if you go and really look in, and if you can develop a system the way I showed you in the middle of my presentation, a system that has a coal through gasification, through multi-generation, through hydrogen, CO2 capture, when it is a system virtually what I call an integrated multi-generation system with zero CO2 emission, it is same, it is as good as a solar or wind. Only thing is, it's the economics. That's what we need to compare with a solar-based system to see if it stands, or way how to bring it down, or how to develop. That's where we are heading, or that's where things will be headed. So that's where this goes on, talking about all those things, biomass. So the overall the story is, I'll put back again here the heading. This I will be emailing. It gives you, really I tell you, whenever I read, or when look into this article, it gives so many sides. So it is going to be very helpful. At least I tell you, not many times we try to do research bringing these factors into picture, because we always look on doing some analysis experiment and looking performance, efficiency, parametric role. We try to vary these, that, but we everybody, everywhere we may not get research opportunity, but when there is a research opportunity, I think one needs to look into sustainability side of any energy source, any engineering system. Let me put this way, I'm taking out hydrogen from the discussion now, time being. You take any engineering system, you take any energy system, please. So we need to do the details, provide the details, bring out the details in a way that the details related to sustainability are brought out. I think one of the, I think in this title of this FDP, I know it is a hydrogen side, but it also talks a lot about sustainability side. That is the reason why I choose to highlight some of the details, so that some of you may at least even think, may plan to have a PhD scholar, work on some maybe a IC engine, that don't look only IC engine from different fuels, hydrogen, these, that, look also sustainability side, look also looking into various indicators. So that will, that way it is going to have a big impact. There are other papers too, but since there is a time limitation, I cannot. So let me go back to the presentation. So that's where it gives you a lot of these things. Okay, now this article, as I said, I will email to. I really tell you, we were very fortunate to have a scholar like Nirmal Vijay, a postdoc. A PhD too, but the thing is, postdoc did tremendous work. Sometimes, let me tell you, see, the role of professor when you get a good scholar is very limited. They bring you more details, they bring you more discussions, they actually produce more in a way. Just by looking at a right way of doing things, right way of guiding, you get benefit. It's not that we try to do, don't think that I did all this, it is the students who do, but we look into and we work together, so that way in the process, details comes out. Okay, so now, at least, what is some takeaway from this today's FDP for you as a participant, as a professor, as an attendee? So as I was saying, there is a tremendous opportunity, please. Hydrogen is going to be a very important energy part of the system, not for one country, not for India, not for US, Canada, or China, for the globe. And reality is, let me tell you this way, even this hydrogen is being spoken, even I tell you. So when initially, I attended one conference in 1999, I think. No, yeah, 2001 or something like that in Canada, in Vancouver, okay, a city. I heard from a big executive of a fuel cell based company that hydrogen based buses, hydrogen based vehicles will be there in on the streets in next, probably the word used was like 5-6 years. So now we are in 2024. Even today, if you look, anything that I am saying, you can go and look afterwards. You see, yes, hydrogen is produced in a big way. You saw the mix, but most of the hydrogen that is produced is used in industrial applications, not in any transportation sector. So that means there are issues, there are challenges that have to be addressed before what these executives, what the companies which are funding, what the agencies that are funding, they can see in reality those type of systems. Because if we can have hydrogen vehicles, buses, scooters, whatever you name, we will solve half of the pollution problem in cities and health problems. But still the question mark, we don't have. I mean, I'm not saying it's not something it needs. There are issues that have to be. So there are a lot of advances, there are a lot of opportunities. And if you particularly look, I did not show you anything in the wind, but wind is also gaining popularity, please, because you can produce power through wind, then produce hydrogen through electrolysis. But I did highlight through solar. You will be getting that article. I did show you there. What did I show you? Yes, electrolysis is great. You produce power through solar route, then produce what you call hydrogen through splitting water into H2 and O2. But the question is, what is the cost? If you have noticed in from the slide that I showed you, the cost of it is almost 2.5 times when you compare with natural gas, even more. So meaning is, today, ultimately, whoever is using hydrogen, they want cheaper hydrogen. They want hydrogen that is available at less price. So that means who wins? Natural gas wins. Then how can we make solar to win in a big way? Not just by speaking, not just by talking. I tell you, sometimes you may hear from somebody saying, oh, this solar will change the world. Solar energy is available in plenty. That is the truth. But do we have the research and technology developed in a way that solar can overthrow completely others? That is where the question mark, that is where research opportunities like that, there's a huge research that goes on how to capture carbon dioxide from these systems. Then the question comes, role of solid fuels. I showed you plenty of opportunity. Then we cannot ignore economics. Economics is part of any system that we talk. Sometimes, it's not only you or me, any researcher, unless we have all the details put together and compared on apple to apple basis, we get as such the real information, correct information. Otherwise, we may not have the exact information to say that this is better or that is better. So, and if you notice this last one, try to notice. A lot of people are doing now even how to store hydrogen. It is not, I mean, whatever you saw is hydrogen production discussions. There are a lot of research that happens on hydrogen storage, how to store hydrogen, because hydrogen storage is a issue. How to take this hydrogen. Then, if you are talking about using hydrogen in a big way for fleet like buses, trucks, vehicles, these, that, now you need to have the infrastructure. That means nowadays when you drive a car, if you want to refuel it, you are going to stop in between. And then you are going to refuel it, continue your journey. Whether you are driving 400 kilometers in a day or 600 kilometers, you have refueling stations. So you are not worried. But for hydrogen, if it has to come in a big way, not only production, not only the technology developments, we need to have infrastructure. That means when you are driving a fuel cell based vehicle, which is operated through hydrogen, now after 200 kilometers, when you are almost done, let us say, you should be assured that there is a station available to refuel. This is what I am telling you. Even California, which people say is like the one which pioneered this hydrogen side of thinking and research or development, even today, they have very limited infrastructure. So it's a long way, but it's a very promising way. But we need to work. Our research has to be done in a way that hydrogen becomes a big way, and that helps. So I think some challenges, some contributions, advantages, opportunities, I try to show you. So that way, I hope this supplements all the knowledge that you already learned in the last 5 days, maybe going extensively people on hydrogen side of discussion only. I think with that, again, I thank all my, I owe a lot to, after my parents, I owe a lot to my great guru, Professor PK and all, it is his guidance or his good words, what makes us to work or, to contribute. And then to my universities, wherever I work, my students, collaborators, funding agencies, I also want to thank this ATAL FTP program, and then the coordinator, Professor PV Kumar, and the organizers of this FTP program at LBR Engineering College. So we do have some time for interaction or questions in general on both the lectures, please. Yes, I'm done. So now I am open for any questions that you have. Just give me 1 minute. I just turn off the light. Okay. Yes, please. Now I am ready to answer you in general any questions if you have it. Not only these topics, anything related to thermodynamic energy side, I am happy to answer. Yeah. We're on time. There is a 6 minutes. I think it says 5 to 6:30 now in Canada. Now the time is 7:54. So any questions that you have, please.
Hello, Vishwanath Reddy.
Oh, yeah. Oh, Balaprasad.
I am Balaprasad. Very good morning to you all.
Oh, good morning, good afternoon, good evening there. Very
Of
nice.
course,
I don't know you are there. I quoted your name. Thank you.
For you, it's a good morning, right? That's why I have called.
Yeah, it is 7:54 now. I woke up, but I tell you, I woke up
very
at
sorry
3.
for the trouble.
No. There is no trouble. It is an
Thanks very much for
opportunity
your
to
acceptance.
contribute. You helped through for this. Yes.
Thank you very much for your acceptance, and also the two topics which you have delivered are very relevant to the topic of the FDP.
Yes.
And definitely, every one of us are very benefited on hearing to the sustainability development of hydrogen, in particular. You have given a very good insight. Yeah. And definitely every one of us have benefited, I think. And thank you very much once again.
Yeah, thank you. No, I think I need to all other participants, I need to mention, apart from this FDP coordinators, it is Professor Balaprasad. I think I did mention in the beginning itself. So Professor Balaprasad, and the other thing that I need to share is not only my good friend, best friend, but he's also, we did engineering together. And, so at least the whole idea was, to help you to figure out some areas. I'm telling you, just to add what Professor Balaprasad said, sometimes I'm telling you, please never look at some equations or some details from any presentation. Rather look scope and opportunity, because once we learn basic courses in engineering, all of us are equipped with basic knowledge that is needed. What is needed is, once we know where to go, just to take that system or that direction and work on the details. That gives us the opportunity to publish or do something. Yes. Thank you, Professor Balaprasad. Yes. Yes, I would like to hear a few questions so that, I can respond or I can give some details. Yes, please go ahead.
Sir, good evening, sir.
Yes.
Sir, I am Kumaresan from Chennai, sir.
So, nice, sir. Please go ahead.
So it's very nice presentation, sir. So this is the first time.
Thank you, sir.
It's the first time I attended for this type of FDP, sir. I am basically mechanical engineer. I thought this is fully related to the chemistry, I think. So this is the first time I have attended. How that mechanical engineer to contribute to this, sir. So yes. I thought like this. So I want to how we are going to work. So a lot of chemistry background is there, that fuel cell and chemical is there. So the chemistry people is always come to this. Whenever the topic is coming, so it
Yes.
is for us like that they took. So mechanical, you do some other way to research like this.
Yes.
So
Yes.
I want to clarify it, sir.
Yes, sir. So that is a very nice. I add a few details. Let me tell you, sir. Now the way research is gone are the days maybe where people used to do that. Electrical will do research on their own, mechanical will do on their own. No. Now it is an interdisciplinary research. Anything that we do, sometimes you or me or Professor Bala Prasad, we don't have to be expert in everything. If we try to become expert in everything in lifetime, we don't achieve anything. We have to be a team involving, depending on the topic, electrical, mechanical, chemistry. So in general, when you have the team, they will help where the details are needed. It will help to produce more. So this, I mean, I no doubt you do see a lot of chemistry side of details, but it's a lot mechanical, even chemical. In general, the whole engineering side is a lot hydrogen is involved.
Okay, thank you, sir. Thank you.
Yeah. Oh, very nice, sir. Yes, please. Others. Comments, criticism. I don't say there's a criticism. Meaning is some of the things that I said. If there is anything that you want, please comment so that I can provide some explanation or details. Okay, so I will take maybe 2 minutes, yes, somebody
Hello?
wants to speak, I think. Yeah.
Yes, sir. I am Ganesh Naik from Maharashtra, sir.
Okay, please.
Actually, I am doing my research in biodiesel, actually.
Oh, good.
Yes, sir. Sir, actually, I have some difficulties in that. Many researchers have studied about the emission norms, emission gases. But I found very much less research on particulate matter, PM emission.
Yes.
The reason is actually the instruments which is required for that is very costly, sir.
Okay.
So could you help me in that, sir?
Okay, do one thing, like my email is with the coordinators. You can take my email. So you please put a email with what I mean scope or details you are looking, because even in India, like there are some institutes where they have very good what you call the whatever topic you mentioned, biodiesel, the engine research, the testing, experimentation, even modeling. So that happens because why I tell you is particularly I receive a good number of PhD thesis from Anna University and also from Annamalai University. I had seen some of the very good research contributions and what you call the way they are doing. Maybe what you are looking is matching with them. I can connect you with them. So at least I can help you typically where some sort of similar opportunity or work is going on even in Canada. What I am trying to say is at least I can help you in contact, in making you to contact with the right sources. That much I can help.
Yes,
No doubt.
Yes, sir.
Yeah.
Yes, that is very much needed, sir. Actually, thank you very much.
That definitely there is no problem with that. I will help. Okay.
Okay, sir. Thank you very much, sir. Thank you.
Thank you. Any other questions, comments, please? Okay, I will take now only 2 minutes. I know we are on time because they have valedictory. Let me tell you only what I mean is just to encourage. So please, I mean, what I am saying is sometimes whatever facilities we may have, whatever opportunities may be there in an institute where we work, research is something, just try to figure out even a small topic, a small topic which has to be little contributing. Let us say you took, even I give you simple example. Let us say you are taking waste heat gases coming from a combustion chamber or even a gas turbine. So look at what the gas composition is. What happens, suppose if I had little excess air in that, excess oxygen in that, or some sort of a composition difference, if I am burning coal, if I am burning natural gas, if I am burning some other biomass gas fuel after cleaning. You just vary even the specific heats, gas composition, look into its performance from energy point of view, and these days from second law exergy point of view, and see what entropy changes it will happen. What I am trying to say is, once you have the collected literature, look what can be little more contribution can be made so that advance can happen to the field. If you highlight that 1 or 2 lines in your research when you submit a paper, the papers will get published in journals, top journals. What I am trying to say is, sometime, no, I am only trying to give this word just to encourage you, please. So sometimes we think that, oh, I need to have this, I need to have that, unless I cannot do big research. No, with whatever we have, still we can do if we take that route. I agree. When you have lot facilities, you can do much more. But even with whatever available, there is a lot that can be done. So it all comes down how we plan and utilize. And as I am telling you, I mean, we are all, as I hear from other people who made some comments or questions, or like Professor Balaprasad. See, we are all the same group of people. But only thing is, sometimes how we plan, how we put our time and utilize our time, that's what exactly I'm telling you, second law, is what makes us sometimes to achieve more. This is what, please, you notice it. I'm telling you, you notice whoever has some success, whichever company even has achieved success. You take a company and analyze it from second law, you will notice that they are utilizing the second law guidelines. They are utilizing entropy minimization route. They are utilizing exergy efficiency improvement route. That is where you see their performance improvement is. So my last sentence or word is, please utilize your full potential. See, we as a, as a researcher or faculty or in a role where whatever role you may be, we have opportunity to contribute. It all comes down to how you use it, how you utilize your time. So opportunity is a lot. Even one time it comes back with comments, the paper, but you modify, it gets published. Okay. So with that, I think I thank one more time Professor P.V. Kumar, the organizers of LBR College, for the opportunity. And I should thank, my great friend, Professor Balaprasad, really did put messages to me. Though I was on track for these presentations, everything, but in between he sent me reminders. So I am thanking him too. And I think with that, I stop. Thank you very much. Okay. Yes. I know I am available. Professor P.V. Kumar, I am available. I know you wanted. Okay. Yes.
Yes, sir. Sir.
Yeah.
Thank you so much, sir. After attending a very important work, you came back to Canada at 12 o'clock and waking up early morning in the 4:30, and you joined the meeting by 5 a.m., sir. So I am very, sir. There are no words to say my sincere thanks, sir. That's what the commitment from you, sir.
I think I will maybe I'm interrupting you for a minute. No, see, Professor Kumar, as I said, this is an opportunity for me to present something helping back the motherland. So never it is. Yes, I agree. When I slept yesterday night after I spoke with you, everything, it was 1 a.m. Then I woke up at I tell you around 4:15 a.m. 4:30 because it took half an hour for me to do my things before I sat on the screen. But it is an opportunity, always. Thank you. Yeah.
Thank you so much, sir. Please be, sir, in the meeting for under 10 minutes, sir.
Yeah, I'm here. I am on the line. I am here. Okay.
Okay, sir. Thank you so much, sir. Now it's time to take the feedback from the participants. Dear participants, please give your valuable feedback. Hello.
Good evening, sir.
Yes, sir. Tell me.
Am I audible to you, sir?
Yes,
Yes,
sir.
yes, I can hear. Yeah.
Yes, sir. Yes, sir. Sir, myself, Dr. V. Suresh, sir. I am from Godavari Institute of Engineering and Technology, Rajahmundry. So
Wow.
first of all, I would like to thank to convener and the coordinators of the event and management of the Lakredi Balreddy College of Engineering. Sir, we have learned so many things on this FDP, sir. So every session is a very wonderful and very fruitful information I learn and received, sir. So thank you for this opportunity, sir.
Thank you, sir. So any other participant? Hello? Hello? Hello?
Evening, sir. My name is Raghuvamsi. I am from Gudlavalli Engineering College, sir. Sir, I have attended all these sessions where sessions covered a lot of information starting from generation of hydrogen using different methods and which is covering the storage methods also. And especially in today's lecture, actually sir focused on application by taking combination of various cycles. So all the sessions are very much informative, sir. And the points mentioned by the today's lecture, they are highlighting the need for concentrating on important aspects. So very, very thankful to Lakredi Balreddy Engineering College, sir. Thank you.
Thank you, sir. Any other participant? Hello? Any other participant? Please give your valuable feedback.
Am I audible?
Yes, sir, you are
myself
audible.
Mahesh Arora. Sir, I am Mahesh Arora from Lingyal Vidyapeeth, Faridabad, Haryana. I am pursuing my PhD in mathematics. I see this was very helpful and supporting. So, me so much. So, how can I proceed in such? I am very thankful to all of these doctors and such. So much. Thank you.
Any other participant? Please unmute
Yes,
your
yes.
mic and give
Myself,
your valuable feedback.
Sunny, speaking from Government Engineering College, Dahod, Gujarat. So we are thankful to the organizers of this program, coordinators, directors of the institute for arranging very well program regarding the recent advances in the renewable energy. We can get lot of knowledge through the using and utilizing solar energy for harvesting the free sustainable energy source, some hydrogen based manufacturing, its storage, transportation, and likewise. So we may explore certain new and innovative ideas in the case of the renewable energy. Thank you all for considering the request for attempting this program. Thank you, respect.
Thank you, sir.
Hello. Sir, good evening. Am I audible?
You are audible, ma'am.
Good evening, everyone. I am Dr. Allirani from Sri Ramakrishna Engineering College, Tamil Nadu. I am from electrical background. So the sessions, I didn't know much about hydrogen energy, to be frank. But I have searched for this topic. I have registered for knowing more concept on this hydrogen generation, storage, and utilization. So this institute have organized a wonderful FDP with all ASC, NITs, and IITs professors. It's very much appreciable. What very good content as I'm from other domain. So I'm very much thankful to the organizers and the institute and for the ATAL AICTE for organizing such wonderful event. Thank you all.
Any
Thank
other
you, madam.
participants?
So all the participants, meanwhile, please switch on your videos. All of you switch on your videos. We'll take a snapshot with our expert. Please switch on your all of you, please. All of you, please. Hello? Dear participants, please switch on your videos for that's all. Hello, sir. Hello? Hello, sir.
Hello, sir. Your audio is breaking.
Photo తీసుకున్నాను, sir.
Yes, sir. Yes, sir. We collect. Taken, sir.
Please take a screenshot. Take a...
Okay, now close our video, sir.
Madam, please.
Yes, sir.
Hello? Madam, please go ahead now.
Yes, sir. So, dear participants, now our FDP program has come to an end, and now we will start our valedictory session. At first, Dr. P. Vijay Kumar, sir, Department of Mechanical Engineering, who is working as professor from Lakreddy Valedictory College of Engineering, will give you the overview of this FDP program. Sir, please go ahead, sir.
Thank you, madam. So, respected chief guest of today's valedictory function, Dr. Pallavi Reddy, sir, professor from Canada, and all other esteemed participants. Very good evening to one and all. So, it is my pleasure to say a few things here. When we applied for this FDP, we are not guarantee that our proposals will be selected. Okay. So with we are having something in our mind, because the topic was something different from other topics. Even though so many proposals were sent to AICTE ATAL FDP, we were having a small kind of hope. So because of the efforts of we did our level best to send a good proposal. So it was we are lucky enough to get our proposal got selected. Okay, I thank AICTE ATAL FDP wing for sanctioning this FDP to our college. And secondly, I would like to say my sincere thanks to all the resource persons who are drawn from various prestigious institutions,
Especially, I thank sincerity. Sir has actually of giving 2 different sessions on 2 different dates, but because of his sir's busy schedule, it was not materialized. So, 2 sessions at a stretch for 3 continuous hours. Thank you so much, sir, very much for your commitment, sir. Next, I would like to thank all the other resource persons, Dr. Anandyam Shivapuji from IIC Bangalore, Dr. A. Ramesh Professor from IIT Madras, Dr. E. Anil Kumar, Professor IIT Tirupati, Dr. D. Jaikrishna, Professor NIT Warangal, Dr. M. Shankar Rao, Nanosol Energy Private Limited, Hyderabad, Dr. Mr. Yan Vinod Kumar, Director, Jaswit Cryo Private Limited, Mr. G. Prasad Rao, Executive Engineer, Thermal Power Plant at Vijayawada, and Mr. V. Sethuram, Team Lead, is working in the software company in Bangalore. So I thank all these resource persons who made it possible because of their contribution and commitment. Thank you, my all distinguished resource HOD and in charge HOD, and my fellow coordinator, co-coordinator Dr. V. Dhanraj, and co-coordinators Vishwanath, Lakshmi Prasad, Mallikarjun Rao, and Kamal Prem Madam, she was very reading the profiles of the resource persons, and also other faculty members who contributed directly and indirectly, and non-teaching staff Jamal Reddy and Venkat for staying back in the college up to 9 o'clock. And not the least, but the principal, sir, and management who kind enough to support whenever we go and ask them to conduct such type of FDBs or other events. They were always encouraging us to conduct such programs. Thank you, principal sir and management of the college. Now I would like to hand over the session to Kamal Prem Madam.
Thank you so much, sir. Thank you. And now I am inviting Dr. M.B.S. Srekhar Reddy, sir, Professor and Head of the Department Mechanical Engineering from Lakreddy Baladi of College of Engineering, to give few words.
Respected Chief Guest, Dr. B.V. Reddy Garu, Professor, University of Ontario Tech, Canada. Dear participants, good evening one and all. I observed this FDP on green hydrogen is a very unique one with different resource persons from NITs, IITs, industries, research organizations, foreign universities on a single platform. In the past 1 week, we all have gained knowledge on green hydrogen from the fundamentals to the latest developments. Hydrogen energy is not much explored so far. So this FDP has given a path for all of us to start working towards green energy. Green hydrogen is not only just a new technology going to come, it is the desperate need for all of us, for the society and to the environment. So let all of us contribute whatever we can to the green energy. At the outset, I would like to take this opportunity to extend my gratitude to all the resource persons. I thank Professor B.V. Reddy sir for spending his valuable time for us. I thank all the participants for their active participation in all 6 days. I thank the principal sir. Without his motivation, we will not come forward to conduct these kind of events. I thank the coordinators for the successful conduction of the program. Thank you one and all. Thank you for giving this opportunity. Thank you all.
Thank you, sir. Thank you. Now, I'm inviting our today's resource person, Dr. Reddy sir, and he is our chief guest today. Sir, I'm requesting you to give your valuable words regarding this FDP.
Yeah, okay, madam. So thank you very much. So as I said, first I would like to thank the coordinator, Professor Kumar, and HOD Professor Reddy, and also madam, just now you mentioned also the Lakhireddy Balreddy College of Engineering for the opportunity to present two sessions in one day. As I said, it worked well for me because of my other commitments. Okay, so I won't take too much time. I may take 5 minutes to give you some details. One, uh, so as the coordinator was mentioning, I noticed one word. So the coordinator used the word lucky. So let me put this way. So, whenever we are doing something, when you think in the right direction, pick a right topic which has importance, then the chances of success is very high. So that means, I know luck may help, but usually many times what helps is the right topic. If it is research, whether it is for paper, publication, project, and what it is going to contribute. So when even I saw the title, when I got the email, I was very impressed. So it is the title and its impact. Even when the reviewers will review it at the ATAL FDP level, I mean, they may see at least will it contribute something to participants. So what the first thing that they look is the title. So here it is absolutely very nice title which has two things: hydrogen, sustainability, technologies. So I think what I am trying to derive or give a message to the participants here is, so even in research it is the same thing. Please, if you are working or to publish a paper, this is what I was telling, what you are trying to contribute, if you can highlight. It's not that everywhere everybody every paper doesn't bring a breakthrough research. Sometimes we may be contributing very small information only, but if it is projected in way how big its value could be, that will get published in top journals. So the message I am trying to convey is, sometime see what you are trying to contribute, how it is going to be different, innovative. That's all. A little work you can publish in top journal. So, and the second, yes, again going back to the same coordinator words, I am telling you, even when you are planning for any research projects, so the relevant areas, upcoming areas, new areas, which can have some value, some importance, if you propose project in that, the success is going to be very high. No doubt. Sometime, our publications, what we do may also contribute, but sometimes it's not that somebody is venturing into a new area, they may not have a publication. So just because they don't have a publication, it's not going to be funded. It will be funded. So key is always identify some upcoming areas and prepare well. The third thing I want to say is, in anything, even whether it could be presentation as a lecture, presentation as a report, presentation as a research proposal, how we present things also matters. If we write things in a way whoever is reading even can't understand, even if it is a breakthrough area, it is not going to be funded, it is not going to be selected. If we say that what it will contribute in a way it could be understood easily, what benefits it will provide, it will get. So the last one, yes, I do agree. I mean, sometimes it seems ATAL FDP success rate is very low. So on that count, I think definitely I want to praise all the coordinator, HOD, the madam, whoever is involved, including the management who supported at Lakhireddy Balreddy Engineering College. I think this is one of the college that I am going to deliver in some NITs and other institutes, but this is again for the college, it is an achievement. Now the last thing I am telling you, whether it is a college, whether it is you or me, how do we get noticed? A college doesn't get noticed through buildings. Even if somebody builds 100 buildings, If no activity, no publications, no events happen like this, then hardly people will know that college. By conducting events like this, that is through their success. Now you see, I hear participants. I saw somebody talking from Tamil Nadu. I saw somebody talking from Bihar. Just now I saw somebody from North. So meaning is, I mean, now the LBR college name is known not only in one state. Now it is known throughout India. Now maybe a little bit, there may be things happening now through the motivation and support from the management and HOD. If faculty members get projects and publish and start doing big research, it will be known internationally. Definitely it will. So what I am trying to say is, for an organization, it is not just the buildings that will promote or bring name, not even the advertisements in newspapers, events like this, whether FDPs, workshops, even seminars, conferences. So I think in future, they can plan to hold things. And now since I got familiar, now I never visited, but definitely next time when I get opportunity, I will be coming to that college. So what I mean to say is, bringing network, bringing this what you call the relationships with institutes will promote the institute. Okay, now last point, now coming back to our participants, or in general, we are all in the same boat, whether you work in research side of a company or professor or this. So for us too, same thing. If we want to be known, the only way we are known, whether within India or outside, is through publications or research projects. So the key is, please identify a project that has current relevance. And on that count, I am telling you, if you are going to have anything related to energy, environment, sustainability, hydrogen or solar, renewables, what I am saying is, in engineering, typically energy, environment, sustainability, other than IT side like cyber security, machine learning, artificial intelligence, a lot of those things which people talk, smart energy, if it is electrical. So what I am saying is, focus an area where it is upcoming. Even if you are not into that side, slowly move to that side. So what happens is, your opportunity will be more. If imagine you or me, we are in mechanical. If we struggle to do research, don't mistake me for my words. If we struggle to do research in turbulence or in fluid mechanics, the chances of me publishing, you publishing, or me or you getting a project support from any agency is very limited. Suppose you jump in like this, hydrogen or sustainability or something, and even how much it is written, how well it is written, still people want to fund you because they think you will contribute something. You are going to contribute for the money that is supported. So the key is always publish. There is a saying, if you are in research, in teaching, you publish, or perish like that. You pick a good area, apply in that, and then have collaborations. I tell you, as an individual, you or me, we can do little, but we team up like 2 or 3 people, or a collaborative approach, that with little effort from each individual will produce much more. That means you can get more publications. At the end of the day, now even in India, I come twice 2 times minimum to India every year. But what I am trying to say is, there is a opportunity for research. Also there is a competition. People, managements, colleges, IITs, whichever institute, they expect more from professors. So that means you have no choice now to do research. If that is the case, why not choose the good areas, work hard, and make collaborations? These type of events are definitely very helpful. So they did a great thing. And first of all, as I said, coordinator used the word lucky. I don't say it is lucky. It is their effort, choosing in the right area and providing details. No doubt. Sometime when you put even your resource people list is going to be good, that also could be a factor. So with this, I think even I feel I'm very happy, even though I got up early, I spent time in this. I feel very happy that I also could contribute a little bit in this overall. So I thank all the organizers for this opportunity. Thank you very much.
Thank you, sir.
Thank you, sir.
Thank you for your enlightening words. And now I'm inviting Dr. V. Dhanraju, sir, Associate Professor from the Department of Mechanical Engineering, Lakredi Baladi College of Engineering. Sir, I'm inviting you to give vote of thanks.
Thank you, madam. I consider it a great privilege to propose vote of thanks for this 1 week online AICTE ATAL FDP on emerging green hydrogen energy technologies for societal sustainability and climate change mitigation, organized by Department of Mechanical Engineering, Lekkeredi Valedictory College of Engineering, Mayilavaram. First, I sincerely thank to the management of LBRCE for giving us an opportunity to organize this online FDP successfully. I would like to thank our beloved principal, Dr. K. Apparao sir, for motivating and encouraging us to conduct this online FDP for benefit of the faculty and research community. I take this opportunity to propose vote of thanks to all the resource persons for enlightening the participants with advances technologies in the field of hydrogen production. Day one, I thank Dr. A. Anand Sivapuji, Senior Research Scientist, Center for Sustainable Technologies, IIC Bangalore, presented an insightful session on green hydrogen from bioresources, pathway, potential and challenges. I thank Dr. A. Ramesh sir, Professor, IIT Madras, presented an informative session on hydrogen-fueled internal combustion engines for stationary applications. I thank Dr. D. Jaikrishna, Professor, NIT Warangal, presented on hydrogen generation using solar energy and its relevant challenges. I thank Dr. M. Shankar Rao, Director, Nanocell Energy Private Limited, presented an useful topic on green hydrogen production and its future in the context of increased climate change, followed by Dr. E. Anil Kumar sir, Professor, IIT Tirupati, presented an enlightened topic on hydrogen and energy storage for sustainable energy systems. I thank Dr. G. Prasad Rao sir, Executive Engineer, Dr. Narad Atarov, Thermal Power Station, Vijayawada, presented on topic on adoption of green hydrogen technology for hydrogen generation in thermal power plants, benefits and challenges. I thank Mr. N. Vinod Kumar, Director, Jesuit Creo Private Limited, Amaravati, presented on hydrogen energy generation and its future applications. I thank Mr. V. Sethuram, Lead Engineer, Global Quest, Bangalore, presented on hydrogen production from wind energy. I thank Dr. T. Srinivasarao sir, Professor, NIT Jalandhar, presented on hydrogen energy thermal poly generation. I thank Dr. B. Viswanatha Reddy sir, Ontario University, present on two sessions, sustainable development role of second law thermodynamics, followed by advances and developments in hydrogen energy technologies. Thank you, sir. I thank Department of Mechanical Faculty, especially the coordinator, co-coordinators, technical staff, who made this FDP in successful manner and able to reach the expectations of all the participants. Last but not the least, I thank all the participants for showing their interest in this program and also for their active participation. So thank you once again. Thank you one and all. Thank you, sir, for your patientful and wonderful lecture today.
Oh, Professor Dhanaraju, I forgot
Yes, sir,
to
yes,
add
sir.
you to the list of acknowledging. Thank you very much. Because you as a co-coordinator contributed a lot in this, success of this event. It's not
sir.
easy to organize an event.
Yes, sir. Yes, sir. Thank you, sir.
So we are done now, I think. Is it?
Yes, sir. Yes, sir.
Okay. Thank you very much. See you
Thank you,
all. I wish you good luck. Okay. Bye.
Thank you, sir.
Yeah.